Okay, welcome to our tutorial for page 1 for the Chapter 9 test review in Algebra 1. So if you're watching this, you struggled a lot with square roots, simplifying them into simplest radical form, and then identifying the number of zeros of a function. So we're going to start, just go right in here in order, start with number 1. So this one, we're trying to simplify the square root of 72. So we're going to start with just a simple single number. With this, remember we're trying to break this down into the biggest perfect square and something else. So whatever that other number is that multiplies together to get 72. So if you have a list of the perfect squares handy, if you want to, remember, you're not going to have that given to you. You're not going to be able to have that on a sheet written down anywhere. But if you want to make a list for yourself in the margins of your test tomorrow, you are allowed to do that. So just start going through and just squaring all the numbers. It could be helpful for you. I don't think it's super necessary, but again, that is up to you if you want to go ahead and do that. So what we should come to the conclusion of is that 36 is the biggest perfect square that goes into 72. Because if the number is smaller than 72, it would be 64, which does not go into 72 evenly. 49 does not work. 36 is the first perfect square that goes into 72 if we're working our way down. And 36 times 2 gives me 72. So I'm going to break this down into the square root of 36 times the square root of 2. Because I know product rule tells me if I have a number underneath a radical that can be written as a product, I can split it up into two separate radicals. Because what that allows me to do, I know the square root of 36 is just 6. And the square root of 2 does not simplify. So my final answer is 6 root 2. 6 times the square root of 2. And that's it. For number 2, we now have a fraction. So I'm going to have to use quotient rule first to break this up into two separate square roots. So I'm going to split this up so the top is one radical, so 25x to the 6th underneath my square root, and then the square root of 4 is my denominator. And from here, we're just going to focus on one part at a time. So I'm going to focus on my denominator first, because that looks the easiest to handle. I'm going to get that out of the way and just say, hey, look, square root of 4, so that's just 2 underneath. Nice and easy. For my numerator, my square root of 25x to the 6th, I'm going to treat my numbers and my variables separately. I'm going to just keep them separate. So for my square root of 25, if I split that up into just the square root of 25 times the square root of x to the 6th, square root of 25 is just 5. I guess 5 times itself is 25. For x to the 6th, when we're dealing with variables now, remember we're looking for pairs of numbers, or in this case pairs of x's, that we could take out of your square root. So in this case, if we have 6 x's, we could make 3 pairs evenly out of those 6 x's. So x to the 3rd power can come outside that radical because that's how many pairs we have. Exactly 3 pairs. And with nothing left over, we're done. Nothing underneath the radical didn't simplify. So 25x to the 6th underneath my square root became 5x to the 3rd, and my 4 just became 2. So we've got 5x to the 3rd over 2. I'm just going to make that bigger here for my key that I'll post to Classroom. Okay, for number 3, we've got just a more advanced version of that same problem. So I'm still going to start by just splitting this up by numerator and denominator. So 216 y to the 7th over the square root of 49 x to the 8th. And again, I'm going to start with my denominator just because it looks a little easier to handle. Square root of 49, well, that's just 7, right? 7 times itself is 49. And for my variables, I've got x to the 8th power, which is exactly 4 pairs. So x to the 4th is what that simplifies down to. And since both parts of my square root simplified out, I don't have that radical in the denominator anymore, which is good. Up top, a little more complicated, because 216, not a bad number, but not the nicest number, not something we're used to dealing with. So you're probably going to have to do a little scratch work to figure out what that breaks down into. So 216, if we try and test some different perfect squares, we should eventually, even if it's not quick, eventually come to the conclusion that that's 36 times 6. So 36 in this case is the biggest perfect square that goes into 216. So when I break this 216 down, 36, when I take its square root, is just 6 outside of my radical. Right, that's this one, because this is really what I'm doing over here. Square root of 36 times the square root of 6. So my square root of 36 just becomes 6 outside of my radical now. And then I still have that other 6 underneath my radical. For my variable, I've got y to the 7th power. So of those 7 y's, I could evenly make 3 pairs. So y to the 3rd comes outside. But I had 7 of them, so I still have 1 more left over still underneath. So I end up with 6y to the 3rd square root of 6y all over 7x to the 4th. And once again, I'm going to go ahead and drag this down, make it a little larger. Good. Okay. For the last one in this section, number 4, it's probably the second easiest question actually. All we're doing is breaking this down into perfect squares and other stuff. So for my for my numbers, 45, that is just 9 times 5, right? 9 being our perfect square in this case. So the square root of 9, that's just 3. And then my 5 is still stuck underneath my radical. All right, because we're doing this over here. Follow the green. That's the square root of both of them. So I'm doing the square root of 45. Square root of 5 times square root of 9. Square root of 9 is just 3. And then for my variable, I got m to the 9th power. So that is 4 pairs with 1 left over. And I'm done. So if you're still struggling with simplifying your radicals, obviously you can rewind and watch that section over again before you listen to the next section, which would be 5 and 6, finding how many zeros and solutions we have. If you're still really struggling with it, you can always go back to our notes and homework from this section, which would be 9.1. You always got the resources of your textbook. You can go back on Google Classroom and listen to the recording from the first time that you learned this way back 2 or 3 weeks ago because of map testing. Just, you got tons of resources. Just put in a little bit of work. You'll be fine. All right, for the last 2, you are finding the number of zeros of a function. Not what are the zeros, find the solution, or not solving this equation. You're just telling me how many zeros there are. So remember, zeros are the same thing as solutions, as x-intercepts, as roots, all of those things we found last chapter. So in this, remember, if we're just trying to figure out how many there are, in 9.5, we realize that that part that's underneath my radical in quadratic formula, this b squared minus 4ac, that helps me figure out how many solutions there are without having to do the whole problem. Because in this, if your b squared minus 4ac is positive, you'll have plus or minus here, which gives you 2 solutions. If b squared minus 4ac was 0, plus or minus 0 doesn't change my equation at all, so it just becomes negative b over 2a, so you get exactly 1 solution. And if b squared minus 4ac was negative, that gave you no real solution because we can't have a square root of a negative number. So all we have to do here is just use my discriminant to figure out what the value is. So if I'm using b squared minus 4ac in this situation, my b is 3, so 3 squared, minus 4, my a is 1, my c is negative 4. So that gives me 9 minus negative 16, which is really like adding 16. So I get 25. So since that number is positive, right, it's bigger than 0, that tells me there are 2 solutions, 2 zeros. And here, don't get hung up. If you write two solutions, I'm not going to mark it wrong. The really big thing that I'm looking for here is that you're showing your work with using the discriminant and that you can tell me how many there are. Doesn't really matter to me what word you use. Here I just wrote zeros because that's the phrasing that I used in the directions. Okay, we'll do the same thing for number 6. We're using b squared minus 4ac. In this case, my b value is 6, so I've got 6 squared minus 4 times my a value of -1 times my c value of -9. So here, -1 times -9 is going to be positive for both of those. Negative times a negative is positive. That gives me 6 squared, which is 36, minus 4 times 1 is still 4, times 9 is 36. So I end up with 0. That tells me there is exactly one solution to that equation without having to solve it. Again, I don't care what that solution is. I don't care what that 0 is. I just want to know how many there are. So you just have one solution, 1, 0. So if you're still struggling with that, obviously, again, you can rewatch that section over again, listen to the walkthrough again. You can go back to 9.5 in our notes, would be where this shows up on our notes that I typed up and gave to you in class. They're on the back side of the quadratic formula notes. Obviously, you can go to that section in your textbook as well to look more about the discriminant. That does it for this first page. Go ahead and pull up the other 2 videos if you are confused on pages 2 or 3, and I will see you guys tomorrow.